I know this is what you guys have been waiting for, because I know I told you from the beginning of this video that if you want to be very good at mathematics, you need to grasp the topic subject of the class. I know most of you will be like, man, this algebra is so simple. Let's get on to the real the subject of formula. Remember, once you know this topic, you know mathematics. Let's get started. Subject up there for formula. Yeah. What is subject of formula? Now, subject of formula actually means expressing one of particular thing in terms of others. That is, making something the subject of formula. We all know that formula means a group of letters that implies a particular rule. And when you talk about a subject of a matter, if I did my English quite well, when the subject of a particular sentence is actually the particular thing we are talking about. So you're talking about the subject of something. It actually means that thing you are concentrating on, that thing you are talking about. So when we talk about subject of formula, it means expressing one of particular things in terms of other things. That is making that particular term or particular quantity stand out, stand alone. I'm talking about it in terms of others. Now, for instance, when I have a equals to pi r squared, as you can see right there, a is made the subject of formula. Why is a the subject of formula? Because a is standing alone. A has become the subject. Whenever we talk about a, we are talking about pi r squared. Or whenever we talk about pi r squared, we are talking about what? A. So a standing alone is making that the subject formula. So whenever I'm talking about subject formula, it just means making a particular quantity stand out, stand alone. Now, I will talk about case one. I decided to split it up in case so we'll understand better. Now, case one is if you have an equation like this and you want to make x subject formula. Now, in this case, I'm going to be making x the subject formula. In everything I do, I'm going to be making x the subject formula, so it will be monopoly. It won't be confusing somehow. Now, x plus y equals to z. Now, in this case, if you want to make x the subject formula, making x the subject formula means making x stand alone, either to the left hand side of the equation or to the right hand side of the equation. Because in an equation we have the left hand side and the right hand side. So in this case, if you look at it, x plus y, between x and y is plus. And you see that what is disturbing x from standing alone is plus y. So what do? You move this plus y to the other side. So when you move this plus y to the other side, what happens? Y becomes negative. Why? Because the opposite of plus is minus. So whenever a sign crosses, or whenever a term crosses to the other side, to either side, it changes its sign. This has moved from the left hand side to the right hand side, so it has changed to minus y. Even if it had been from the right hand side to the left hand side, it should change the sign. So whenever a term moves from one side of an equation to the other side, it changes its sign. So what we've done here is to move this plus y to the other side, which it becomes minus. So we're having this 0 right here, minus y. So what has happened? By moving this plus y away, you're now left with x. So x is standing alone now. So x is equal to z minus y. So by x standing alone, it means x has remained the subject formula. Case 2. Now case 2 is if you're having, of course, a synonymous case to case 1. X minus y equal to z. What is disturbing x on standing alone? Minus y. So what do you do to minus y? Move it to the other side. And once you move it to the other side, what happens? It becomes plus. Why is it plus? Because it was minus here. Once it's minus, if you move it to the other side, it becomes what? Plus. Once it's what? Plus. You move it to the other side, it becomes minus. So what do we have? We're having case 3. Now case 3 is when the The how am I going to phrase the quantity disturbing x from standing alone is separated by multiplication. You see right there that the quantity disturbing x from standing alone is separated by plus addition. So what we do is move, and once it moves, it takes the opposite sign. In this case, if you look at mx, what does mx actually mean? Tell me. Yeah, you got it. Mx means m times x. Remember, therefore means that the sign in between m times mx is times the multiplication sign. So what is the opposite of multiplication? The opposite of multiplication is division. So whenever you have a quantity um or quantities multiplying the particular quantity you want to make the subject of the formula, what do? You use the opposite of multiplication, which is division. So what do? We divide both sides by that quantity disturbing x from standing alone. And what is that quantity? M. So what do? We divide both sides by m. We divide this side by m, we also divide this side by m. Remember, whatever you did to the left hand side, you also do to the right hand side. So by dividing this side by m, we also divide this side too by m, so that the equation will be balanced. So what will happen? M is going to cancel m. That is what's going to happen right there. M will cut off m. Then at the end of the day, x is going to be standing alone. We're going to be having x equal to z over m. So by this, we made x the subject formula. Now there's something I would like to point out here. Nota bene. Mx equal to z. Another way of dividing both sides by m is also by multiplying both sides by the multiplicative inverse of m. The multiplicative inverse of m is 1 over m. So instead of saying I divide both sides by m, it's still the same thing as multiplying both sides by 1 over m, because multiplying both sides by 1 over m is still the same thing as dividing both sides by m. That is, the m is going to cancel the m right there, and we'll now be left with x equal to z times 1 over m. And you know that z is going to multiply this 1 at the top, that is going to be z over m. So x is now standing alone, x will be equal to z over m. So just so you know, dividing both sides by m is still the same thing as multiplying both sides by 1 over m. Case 4. Now, case 4 is like the combination of the case 1 and case 3. When what you want to make the subject of formula is being combined with a quantity by either plus or minus, and also being combined with another quantity by multiplication. So the first thing you want to do is take it in the order of case 1. That is, when you have something being attached to you by plus or minus, move those ones first before you think about maybe dividing. So what do? We'll move the y first. By moving this y first, remember the sign in front of y is plus. So if you move it to the other side, it becomes minus. You have z here already. So when you move it to the other side, it becomes mx equal to z minus y. So you've cut this down to a simpler form. Now you're now having mx equal to z minus y. So what else do you do now? Because now you've taken this y away, you're now left with mx. What you now need to do is what? Divide both sides by m, because now what is disturbing m is x, and between m and x is multiplication, and the opposite of multiplication is division. So you divide both sides by m, and once you divide both sides by m, what happens? M is going to cancel m. In that case, x is now going to be equal to z minus y over m. So now because x are standalone, you made s the subject of the formula. Now there's one thing you need to know here, that z minus y over m all over m is not the same thing as z over m minus y. Please don't get it twisted. Please, z minus y is all divided by m. Please, it's not the same thing as z over m minus y. These are different things. Also, you should also know that z minus y over m is still the same thing as z over m minus y over z, y over m rather. When we get to perhaps operation, binary operation, we'll talk about laws of operation. Perhaps you tend to understand this more better. But I believe right from primary school, you know that this is this. So that's for that. Case 5. Now, case 5 is when you're having two equations being equated to their self. Now, when we're having two equations being equated to their self, first, you also, one thing you should know that when you, once you have equations being equated to their self, and these equations are in fractions, because x over z is a fraction, y over m is a fraction. In an equation, especially in algebra, it might not even be, of course, most times, often it's always in algebra. When we have fractions involving equations or equations involving fractions, the first thing we always want to think about is to clear out the fraction. And how do we clear out the fraction? We clear out the fraction so that the fraction becomes a linear equation. The equation with fractions becomes a linear equation. And how do we do that? We do that by looking at the denominators. Now the denominators in this case are z and m. So what do? We look for the LCM of the denominators. And the LCM of the denominator of z and m, of course, is zm. It's the most simplest way of getting the LCM of variables is just multiplying the variables together. So the LCM of z and m is just multiply z and m. So z times m, that's going to be zm. So what do we do with this LCM? We now use this LCM to multiply each terms. So in this case, we're having two terms on either side, one term here and another term here. So what do? We use that LCM to multiply both sides. Then we're going to be having zm times x over z, also that zm times y over m. So what happens? Z is going to cancel out z right there. Then m is going to cancel out m right there. So we'll be left with mx on this side equal to zy on this side, which is going to be yz. Of course, zy is still the same thing as yz, because if you have 3 times 2, it's still the same thing as 2 times 3. So if you have z times y, it's still also the same thing as y times z. So now the next thing is this: we want to make x the subject formula. We have mx. So what do we do to both sides? Divide both sides by m, and by dividing both sides by m, what happens? M cancels m. So x is going to be equal to yz over m. As simple as that. Case 6. So, case 6 is talking about what if what you want to make the subject formula is having a power. Now, what you want to make the subject formula, whenever it's having a power, what you do is that you use the opposite. Remember, when the opposite, when we have plus and we move it to the other side, it becomes minus. Why? Because the opposite of minus is plus. When we have minus on the other side and we move it to the other side, it becomes plus. Why? Because the opposite of minus is plus. When we have multiplication, we use the opposite, which is division. We divide both sides. Now, when we're having square power, we use the opposite. And what's the opposite? Roots. So in this case, because we're having square, what do? We use square root. So we square root both sides. By squaring root both sides, the square is going to cancel the square roots. So by that, will now be left with x. X will now be equal to square root of k. So even if we had cube here, or x raised to the power of 3, what we would have used with the cube root? If we had x raised to the power of 4, what we would have used is fourth root. So like that, like that, like that. So in this case now, x is now equal to the square root of k, and by doing this, x has been made to stand alone. Case 7. Now case 7 is now talking about what if you now have the root of x equal to k and you want to make x the subject formula. Of course, what's the opposite of root? The opposite of root is power. So what do? You power both sides, and by powering both sides, you raise this to 2, you also raise this to 2. So by doing that, what happens? Square is going to cancel out the square root, and by that, x will stand alone, and x standing alone is going to be equal to k square. As simple as that. So these are the 7 cases on subject of formula. Once you understand all these steps quite alright, you've known mathematics. Mathematics is just at your grasp. It's now for you to make use of all these principles you learned in solving problems, and that's what we are to do right now. So right about now, we start with some examples. Now, the example is like it's having a heading: make x the subject of the formula, or make in terms of orders. Usually, when you are not told make something the subject formula, you will usually be told make it in terms of order. So making something in terms of order and making it the subject formula um goes hand in hand. They are used interchangeably. In other words, so let's make x the subject formula in the following. Now the first one, x plus a equal to b. So the solution is very simple. If we have x plus a equal to b, what do we do? What is disturbing x plus a? So what do? We move it to the other side. And what happens? X equals b minus a. Because x is standing alone, x has made the subject formula. As simple as that. Now number two, a minus x equal to b. Now, in this case now, what is disturbing x actually is a. Also, this minus is disturbing x, but first of all, we'll move this quantity with a to this other side. Let's check the solution. We're having a minus x equal to b. So if we move this a to the other side, remember this is plus a. So I'll move it to the other side, becomes b minus a. Now remember here is minus x. Minus sticks with this x. I've explained that before. So we're having minus x. But this is not the final answer because we are not looking for minus x. We are not trying to make minus x the subject formula. We are trying to make x the subject formula. So how do we do this? Now I want you guys to know. Remember I told you something that whenever you do not say a number beside a variable, that number or that coefficient is 1. So it therefore means that the coefficient of minus x here is what? Minus 1. So what happens is this minus x, which is equal to b minus a, this minus x actually means minus 1 times x. So therefore, we have minus 1x, which is now equal to b minus a. Now, because we want to make x the subject formula, remember that this minus 1x means minus 1 times x, as you can see right there. So what do we do to both sides? I guess you know. What is disturbing s and is multiplying it? So we divide both sides by what? Minus 1. So dividing both sides by minus 1, then we're going to be having minus 1x over minus 1 equal to b minus a equal over minus 1. So therefore, minus 1 is going to cancel out minus 1. Then we'll now be left with x equal to b minus a divided by minus 1. Usually, whenever negative is at the bottom of a fraction, whenever we're having a negative denominator, we usually like to to simplify it by making the negative sign comes up, because what you have at the top is plus. This b minus a is still the same thing as plus open bracket b minus a. Remember the positive sign still multiplying this will still give you this. So plus divided by minus is minus. So therefore we'll be having the minus, or generally once the negative sign is at the bottom, it just moves right up. It moves right up and it becomes the top becomes the negative sign. So x equal to minus inside the bracket of or open bracket b minus a divided by 1, because that is going to be equal to what's that going to be equal to? Of course that is going to be equal to, okay, yeah, right there, that's going to be equal to x equal to minus b minus a, because divided by 1 we're going to be having that. Now remember that also I can also write this as this x equal to minus 1 bracket b minus a, because whenever you don't have anything there, remember there's always 1 in this element. So because of this, what can I do? I can decide to expand this. So if I expand this, minus 1 times b, that's going to be minus b. Minus 1 times minus a, that's going to be plus a. So x, you could decide to leave your answer like this: x equal to minus b plus a, Or you can also decide to leave your answer like this, which would be more preferably x equal to a minus b. Remember, what we've done on this side is to rearrange on this right hand side a plus a, which is a, minus b. We are just rearranging, we are not moving it. Assuming we move this over here, it would have been plus, but no, we are not moving it, we are just rearranging. Remember, rearranging it is different from when you are moving it over to the other side. So when you are rearranging it on one side, the signs doesn't change, it still remains the same, you are just rearranging it. But when you move it over to the other side, once it crosses the equal sign, it changes your sign. And that is what I try to emphasize right here, that if you have 2x plus 5 minus 5x equal to 8x minus 6. Now, this is still the same thing as minus 5 plus 2x plus 5 equal to minus 6 plus 8x. On this left hand side, I just rearrange it. Minus 5y minus 5y plus 2x plus 2x plus 5 plus 5. Now on this right hand side, minus 6 minus 6 plus 8x plus 8x. So what I've done here is that I did not move it, I only rearranged it on either side. But check this out. I have 2x plus 5 equal to 8x minus 6 plus 5y. Now, if I have this 2x, which is this 2x here, and I have this plus 5, which is plus 5 here. Now, if I move this plus 5 to the other side, what happens? It becomes minus 5y. Moving this plus 5y to this other side now becomes minus 5y. Now, moving this minus 6 to this other side changes its sign, it becomes plus 6. And because I'm not moving this one, it sticks right there, which is 8x. So you see now that whenever we move a term from one side to the other side, whenever it crosses this equation sign, it changes its signs. As you can see right there, minus 6 changes its signs to plus 6 when it's moved to the left hand side. Plus 5y, which is on the right hand side, changes its sign when it's being crossed over to the left hand side to minus 5y. Plus 5y has been changed to minus 5y. So you see that whenever we move a term to either side, it changes their signs. But whenever we are arranging it, not moving it, but we are arranging it, as you can see right here, it doesn't change the sign. So please don't get it twisted, because most of us may get this mixed up sometimes. Whenever we rearrange, doesn't mean the sign changes, but whenever the term crosses either side, then the sign will change. So that's for that. Now, number 3, if you have a divided by x equal to b, how do we do this? Solution. Now, a over x equal to b. Remember that this b right here is still the same thing as b over 1. And we're having two equations in fractions being equal to themselves. So what do? We look at the denominators. The denominator is x and 1. What's the LCM? X times 1. And x times 1 is x. So the LCM is x. So what do we do to both sides? We multiply both sides by the LCM, which is x. So multiplying this side by x, what happens? X times a over x, which is right here. Then x times b over 1, which is right here. So what happens? X cancels x. So we'll be left with a equal to x times b, that is bx. And remember that we're trying to make x the subject formula. So what do? On this side, what is disturbing x? B. So this is b times x. So what do? We divide both sides by b. So b will cancel b. Then we're going to be having a over b equal to x. And now, because x is standing alone on this side, so it therefore means that a over b, which is equal to x, is still the same thing as x equal to a over b. What we've just done here is to interchange. Please, it's not that maybe I've moved this one to cross to this side. No, we've just interchanged. It's more or less like saying if 2 is equal to x, it's still the same thing as saying x is equal to 2. This one is different from maybe where we're moving from one side to the other side. No, we are just interchanging. So please don't get twisted. Now, if we'll talk about another example which is coming right up for you on the screen. We are having question number 4, which goes with the solution. So this question number 4, what is the first thing we do? We make the b over 1, because this b is still the same thing as b over 1. And the next thing we do is this. Remember, for a fraction, for an equation involving fraction, whenever we have 8 and want to clear the fraction. I told you whenever you have equation involving fractions, the first thing that should come to your mind is clearing off the fraction. And how do we clear off the fraction? By looking at the denominators, and looking at all the denominators, we look for the LCM. And how do we get the LCM of 2a, 3a, and 1? Of course, I know you know that. And what's going to be the LCM? The LCM is going to be what? 6a. So what do we do with the LCM? We use the LCM 6a to multiply each term. If you don't really understand working with fractions right now, don't worry. Very soon, I'm still going to talk about that topic um, very soon. So use the term to multiply. Sorry, use the LCM to multiply each of the term, which is 6a times x over 2a right there, 6a times x over 3a right there, then 6a times b over 1 right there. So what happens? So a is gonna cancel a right there. A is gonna cancel a right there, and 2 in here 1, then 2 in here is gonna be 3. So what I'll be having will be what? 3x. Now 3 in here 1, 3 here is gonna be 2. So what I'll have is 2 times x, and also there's nothing goes there, so we just have 6ab right there. So we have 3 times x, that's gonna be 3x. This times this 3x, then this. So now what else? The like terms are already beside themselves. So what we just do is to add them up. 3x plus 2x, that's going to be 5x equal to 6ab. And we want to make x the subject formula. What do we do? Divide both sides by 5. And by dividing both sides by 5, 5 cancels 5. X is going to be equal to 6ab over 5. As simple as that. Now let's talk about another example which is going to come right up on your screen just about now. So question number 5, we're having this solution. Now we have this question: the root of x squared plus a squared equal to 3a. Now, one thing you should know right here is this: what you want to make the subject formula, that is the thing that you should be after. What I want to make the subject formula is x, and you know that this x, actually you're having this x squared right here, is under the root. So what you should try and do is to try and eliminate that root first. Check it out. How do you take that out? By squaring both sides. And once you square both sides, what happens? The square is going to cancel out the what? The square root. So that you will now be having x squared plus a squared going to be equal to, of course, when you square this side, that's going to be 3a squared. Now you've got to be very careful here, in the sense that don't make the mistake. Whenever you have everything in the bracket being square, that power applies to everything. So like this square right now, it applies to this 3 and also to this a. So this 3 right there is applied to these two, x and y. Because why is it that it's being applied to everything? Because they are multiplying themselves. So therefore these 2 to the power of 3 is 8, and x to the power of 3 is x cubed, and y to the power of 3 is y raised to the power of y cubed. So therefore we're going to be having x squared plus a squared is going to be equal to, now what is 3 squared? 9. And what is a raised to the power of 2? A squared. So please don't get it twisted, don't mix it up. Don't just write it as 3a squared. No. Remember, everything is inside the bracket, so everything is going to go along for that. So now the next thing now is this: you're having x squared plus x squared. What do you do? Remember, you have to move this away first, so you'll be left with x squared. That is the logic. So once you move a squared away, you're going to be having 9a squared minus a squared. Then you're going to be having x squared equal to that. So therefore you look at this, these are like terms. So what do? You work that out. Then you're going to be having x squared, 9a squared minus a squared. That's going to be 9 minus 1 right there. 9 minus 1, that's going to be 8. And you have the a squared. So 9a squared minus a squared, that's going to be 8a squared. Then you're having a squared. Remember, what do you do? You square root both sides. Once square root both sides, this square is going to cancel out the square root. Then what happens? And that means you're going to be having x left right there. Now also you got very careful here. This root is applying to everything. Just the same principle being applied there will also be applied there. This root is applying to everything. Why is it applying to everything? Because this 8 and a square are multiplying themselves. So therefore I'm going to be having x equal to the square root of 8 times the square root of a squared. It's still the same thing, because the root goes for everything. Now when we get to solve, you're really gonna understand it much better. But I believe from this explanation you should what really understand what I'm trying to explain there. So what happens is this: we know that right here, you could decide to look for the square root of it. I'm sure that's gonna give you a decimal number. You could decide to leave it just like that. This one, this square will cancel this square root. So I believe we're gonna be having x equal to the square root of a times a, which is gonna be square root 8a. So by that we made x the subject formula. So number 6, the period of a compound pendulum is given by t equals to everything right there. Express k in terms of thg, taking pi square as 10. Now you are told they express k in terms of this and this. That means make k the subject of the formula. So how do we do that? Let's check out the solution. Now we're having t equal to 2 pi square root of open bracket a square plus k square all divided by gh closing bracket. Now the first thing you need to do is this: set your eyes on the goal. Set your eyes on what you want to make the subject formula. What do you want to make the subject formula? K. So what you try to do is to eliminate everything so that you try to work towards that k. Now what do you do? The first thing you do is this: you could decide to divide both sides straight up by 2 pi. That's one way to do it, because this 2 pi root of everything here means 2 pi times root of everything here. Remember I told you whenever you have group of letter or numbers being written together side by side, they all means they are multiplying their self. So you could decide to divide both sides by 2 pi straight up, or you could also decide to square both sides straight up, which is this. So by squaring both sides, you have t squared and you have everything here being squared up. So once you square everything, what are you going to be having? You're going to be having t squared equal to 2 pi square and square root of everything square. Now remember that this square is going to apply to this and also to this. Why? Because they are all multiplying themselves. So once we have that, we're going to be having t square equal to 4 pi square. Remember that this square right there is going to apply to this 2 and it's going to apply to this pi. So that's going to be 4 pi square. So we're having t square equal to 4 pi square. Then the square is going to cancel out that square root you have right there. So therefore you'll be having this. Now what do you do? What you do now is to divide both sides by 4 pi square, because you could do it in another way if you like, but I think it is the best to divide both sides by 4 pi square. Why are you dividing both sides by 4 pi square? So that you'll be left with this side only. Because if you can imagine everything here in this bracket as maybe x, so that means you're having 4 pi square x. So dividing both sides by 4 pi square will leave the x alone, so it will just leave this one to alone. That means this is going to cancel out this, and then we have this alone. So therefore pi square is going to be equal to 4 pi square equal to everything right here. Now the next thing we should do is, when you take off the bracket, because you know this and this is still the same thing, so what do? These are two fractions being equated to each other. How can you eliminate this button DH? Mathematics, there are different ways of solving mathematics. You could decide to take out, remember like what we've been doing, this 4 pi square, this GH, you look at these are denominators, you get the LCM, you use the LCM to multiply both sides. But you can also do it in this way, because we're trying to look for the fastest method here. You could do it that way. Once you do it that way, you're still gonna arrive at the answer. But because you want to make k squared the subject of formula, how can you eliminate this gh right there, so that on this side you'll be left with a linear expression on this side? Because the idea of clearing fraction is to make it a linear expression. Remember I said that earlier. Remember, whenever I clear out the fraction, it becomes a linear expression or linear equation. So what do? You could decide to multiply both sides by gh. Why? Because by multiplying both sides by gh, it's gonna cancel the gh, therefore making this a linear expression on the right hand side. Then we're gonna be having 2 squared times gh, which is gonna give us right there over pi squared equal to a squared plus k squared. And by that, you've simplified this to this form. So what do? You take this h squared to the other side, which becomes this minus a squared. So what do you do next? You square root both sides. And by square rooting both sides, square is gonna cancel this square root, and by that, k has been made the subject formula. As easy as that. The idea is making case standing alone. So either way you do it, the most important thing is for you to arrive at the answer. So therefore, what happens is that k is gonna be equal to this. Therefore, I'm saying that k is equal to this. And remember that we are told that we should take pi square as 10. So if 4 pi square, which is the same thing as 4 times pi square, that means 4 times 10, then we're going to be having this as well, 40. So k is equal to this, our final answer. So number 7, make x the subject of the formula in this equation. And also the second question in this same question. Hence, if a is equal to this and y and b, evaluate x. So let's see the solution. Now, we are told that we should make x the subject formula. And after making the subject formula, given that, or if a is 4, b is 1, and y is equal to minus 2, we should evaluate, that is, get the value for x. So we have x over a plus y over b is equal to 1. What do we do? Remember, the first thing we do is try and make it a complete fraction by making this whole number divided by 1. Then what do? We'll look at the LCM. We'll take the LCM of all the denominators a, b, and 1, and that's going to be ab. We'll multiply out through by ab, and when we multiply out through by ab, what's going to happen? A is going to cancel a out, b is going to cancel b out, right? And we'll be left with what? On this side, we'll be left with bx plus ay equal to ab. So remember, we want to make x the subject of formula. So what we'll do first is to move this ay to the other side. So by doing that, we'll be left with bx on this side equal to ab minus ay. It becomes minus here because it was plus here. So what can we also do here? We can also decide to factorize because they are similar terms. So you factorize the a out right there, then you have this. You can decide how to do that, decide to do that anyhow you like it. Your aim here is to make x the subject formula. And how do we do that? By dividing both sides by b. So what happens? B cancel out b right there, then x is gonna be equal to a bracket b minus y, all divided by b, our final answer. So x is equal to a bracket this over b. So for us to solve the second one, we are told that if a is this, b is this, and y is this. So what do? It means that anywhere we see a, we're gonna put 1. Anywhere we see b, we're gonna put 1. Anywhere we see y, we're gonna put minus 2. So by substituting that, we're fixing the values. A is 4 right there, b is 1, we have 1 right there, minus is minus right there, then we have minus 2. So minus 2 is y, so I'm gonna have minus 2 here, but because they are different signs, so I'm gonna open up a bracket. And that is the second function of bracket. So there are 2 major functions of bracket. First is for multiplication, second is to separate arithmetic operation sign. So like we have minus here, we can't just put minus 2 right there to look kind of clumsy. So what we do is we open up a bracket to separate these signs. So and it's gonna be over b, which is over 1. That is for that. So the next thing is this: we'll solve whatever is inside the bracket first. So we're going to be having 1 here, minus times minus, of course you know that is plus. Then we'll also deal with the bracket first. 1 plus 2, that's going to be 3. Then 4 times 3, that is going to be 12 over 1, and that is going to be what? 12 divided by 1, which is going to be 12. Now this question is s equal to 4 pi x squared. How do we do that? Solution: we want to make x the the subject formula. So if we're having s equal to 4 pi x squared, we're having s equal to 4 pi x squared. What do? It's very simple. What is beside x squared here? What is beside x squared here? I'm trying to trying to stress that so we get the difference between s and x. What is beside x squared here is 4 pi and it's multiplying it. So how do you eliminate that? By dividing both sides by what? 4 pi. So if you divide both sides by 4 pi, 4 pi is going to cancel 4 pi. So you'll be left with x squared right there. Then we're having s equals s over 4 pi here. Then s over 4 pi is going to be equal to x squared. We still want to make x the subject formula. So what do we do to both sides? We what? Square root both sides. And by square rooting both sides, what do we have? Square is going to cancel out the square root. Therefore, s is going to be x is going to be equal to the root of s over 4 pi. As simple as that. And that brings us to the end of this topic, subject formula. I believe that you really understand this topic very well. By knowing your algebra and subject formula very well, then you're having a solid ground in mathematics. So what is now left for you is to solve more and more questions. Go out there, go to the libraries, check out books, check out different books in which you have different problems. Try and attempt it and solve it. The more you solve difficult problems, the more you are going to learn the topic very well. But nevertheless, as we continue in this series, I'm still going to bring up lot and lot of questions that we're going to solve together. Because by we solving the questions together, then you gain your solid ground in mathematics. So for now, I thank you for watching. I'm going to see you in the next topic, which is coming right up. Thank you.
I figure 75% to you, Panma, and 25% divided between the 5 of us. Yida, Crowbar, myself, Tom, and the baby. That makes 5% for each one of us.
Billy, you're cheating yourself. If there's 25% divided among the 5 of you, that's 14% apiece.
Oh, no, listen, Pa. I wouldn't cheat you. You know I wouldn't. Now, look here. I'll show you. Let me rub this out here. And now, 25 divided by 5 is 5. You see, 5 won't go into 2, will it? No. But 5 goes into 25 5 times, you see?
No, you're wrong, Billy. Now, I'm a pretty good mathematician. Now, 5 into 25... 5 won't go into 2, will it?
No.
But 5 goes into 5 once. Now, we didn't use the 2 before, so we bring it down here. Now, 5 into 20 goes 4 times. There you are. 5 into 25, 14.
No, look, Pa. Let me prove it to you now by multiplication. 5 times 5. 5 times 5 is 25.
Well, I'm surprised you're learning.
Huh?
I'm surprised that you're learning. Now I'll show you. 5 times 14 is 25. 5 times 4 is 20. 5 times 1 is 5. 25. That's it.
No, look, Ma. Look, you're wrong there because I'll prove it to you. We'll put down 5 14s here. 14. There. Now I'll prove to you by addition that 5 14s is not 25. 4, 8, 12, 16, 20.
21, 22, 23, 24, 25. There you are. Better brush up, Billy. I don't want to see you boys cheated.